What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this quick little video, you're going to learn about wireless network troubleshooting as it relates to RFI, signal strength, misconfiguration of wireless parameters, latency, multiple paths of propagation, incorrect access point placement, refraction, and absorption. Let's talk about radio frequency interference. So wireless communication can be interrupted because of RFI. Common RFI sources that impact wireless networks include 2.4 gigahertz cordless phones, microwave ovens, baby monitors, and game consoles. So it is in your best interest to make sure that you don't have any of those devices next to your wireless access point so that it will not interrupt your signal. Signal strength. So the received signal strength indicator, or the RSSI value, this measures the power of a wireless signal. An RSSI value varies based on distance from a wireless antenna and physical objects interfering with the line of sight communication with the wireless antenna, such as drywall, metal file cabinets, and elevator shafts, etc. Some wireless networks automatically drop their wireless transmission rate when an RSSI value drops below a certain value. So the moral of the story is, if you want decent signal strength, make sure your device has a good line of sight to the access point and make sure that there is nothing blocking the signal if you can help it. Let's talk about misconfiguration of wireless parameters. So a variety of wireless parameters must match between a wireless client and a wireless access point for communication to occur. So for example, the client needs to be using a wireless standard that's supported by the wireless access point, such as the 802.11 ABG N and AC standards. Wireless channels must also match. However, wireless clients usually automatically set their channel based on the wireless access point's channel. Encryption standards must also match, or you will have a security type mismatch. So for example, a wireless client using WPA would not successfully communicate with the wireless access point that's using WPA2. In addition, the service set identifier, or the SSID, of a wireless access point must be selected by the wireless client. In many cases, a wireless access point broadcasts its SSID, and a wireless client can select the SSID from a listing of visible SSIDs. In other cases, a wireless access point does not broadcast its SSID, thus requiring a wireless client to have a matching SSID manually configured. Finally, the most common issue is simply that the wrong passphrase is being used by the client to attempt to access the wireless network. Next, we have latency. So wireless networks, they can experience more delay than their wired counterparts. And one reason for the increased delay is the use of carrier sense multiple access collision avoidance, or CSMACA, in wireless local area networks, which introduces a random delay before transmitting data in an attempt to avoid collisions. Another yet similar reason for the increased delay is the fact that all wireless devices associated with a single wireless access point are in the same collision domain, introducing the possibility of collisions or retransmissions, which too can increase the delay. Then we have multiple paths of propagation. So an electromagnetic waveform cannot pass through a perfect conductor. Admittedly, perfect conductors do not exist in most office environments. However, very good conductors, such as metal file cabinets, are commonplace in offices. As a result, if the waveform of a wireless transmission encounters one of these conductive objects, most of the signal bounces off the object, creating multiple paths or modes of propagation. These multiple modes of propagation can cause data, specifically bits, to arrive at uneven intervals, which possibly can cause data corruption. This problem is similar to multi-mode delay distortion, which is seen in multi-mode fiber optic cabling. Next, we have incorrect access point placement. So wireless access points, they should be strategically located in a building to provide sufficient coverage to all desired coverage areas. However, the coverage areas of wireless access points using overlapping channels should not not overlap. To maintain coverage between coverage areas, you should have overlapping coverage areas amongst wireless access points that are using non-overlapping channels, such as channels 1, 6, and 11 for wireless networks using the 2.4 gigahertz frequency. A common design recommendation is that overlapping coverage areas that are using non-overlapping channels, they should have an overlap of approximately 10 to 15%. Also keep in mind the use of the 5 gigahertz band, which offers many more non-overlapping channels. Next, we have refraction. So refraction, this is the bending of a wave when it enters a medium where the speed is different. It is important to track possible refraction when designing your wireless network, because if a signal changes direction in traveling from sender to receiver, it can cause lower data rates and high retries, and this can lead to an overall lessening of capacity. And then we have absorption. So this occurs when a material is converting the signal's energy into heat. Varied materials have different absorption rates. Wood and concrete can make a significant impact on signal strength because of how much they absorb the radio waves. So that was my quick little class on wireless network troubleshooting, where we talked about troubleshooting issues as it relates to RFI, signal strength, misconfiguration of wireless parameters, latency, multiple paths of propagation, incorrect access point placement, refraction, and absorption. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.